Alright, in this video we're just going to have a look at sign diagrams for cubic inequations. Now we've had a look at this in quadratics, and just as a review, here's an example. So we've got x take 2, x plus 4 greater than 0. So this is inequations. So sign diagram, you got positive and negative. Well, these are our intercepts, so plus 2 being the opposite, so positive 2 and positive 4. And we're going to have a positive graph, which looks like this. So again, we want values which the graph is greater than 0. So what values is greater than 0? Well, it's all these points in here. Just as a review for quadratics. Now we'll have a look at an example because it's very similar for cubics. So we've got x plus 2, x take 1, x take 5, greater than 0. So again, already in intercept form, so that helps. Plus 2, so it's going to be the opposite for the intercepts. We've got plus 1 and positive 5. Now, where does it start and where does it end? So we've got a positive graph because all these are positives. So you're going to start below the x-axis. So down here, it'll go like this. Okay, see the resemblance. So again, just follow that form that goes box shape up and down, and the important part is we start below because it's a positive graph. So we're going positive. If it was negative, we'd be going the other way. But this example is positive. And now we just have a look at for what values of the equation is greater than 0. Well, it's all these parts in here. So our answer is, okay, it's going to be positive or greater than 0 between minus 2 and 1. And for the values for which x is greater than 5 as well. And that just continues on for to infinity. So we've got between 2 and 1 and greater than 5. Okay, next example. We've got 4x squared less than or equal to x cubed. So these are all examples from example 16. So first step, we've got 4x squared less than or equal to x cubed. We need all the variables on one side and we want a 0 on the other. So if we take x cubed on that side, we'll be left with 0. We can take a factor out of x squared, so we'll be left with 4, take an x. X squared times 4 gives me 4x squared. X squared times minus x gives me minus x cubed. What values is that less than 0? Sign diagram, plus minus. Now we've got a negative x here, so we're going to have a negative graph. And that's determined from the x cubed part. So we're going to have a negative, so it's starting above. My intercepts are going to be 1. 0. And actually, scrap that. Okay, we've got an x squared term and a 4 take x term. So this x squared term indicates that it's going to touch the x-axis. So it's a repeated point, like before from the other example. So we've got a repeated point and the other intercept is going to be at 4. So we've got positive, negative, a repeated point at 0. And the other point is going to be at 4. So when we have a repeated point, okay, again, it is still negative, so we start above the x-axis. We just draw it so it touches. So it touches that point there at 0. And it goes through the point 4. Now, the question's asking what parts of x is going to be less than 0. Well, it's all underneath the x-axis, so it's going to be these points here. So we're going to have all points for which x is greater than 4. And that's all that is. And, sorry, it's less than or equal to 0, so we're also going to have 0 as well. So greater than 4 and 0. Do one more. Part C, so we've got x take 2 cubed, take 1 greater than 0. We can almost, okay, so starting with this, let's do something different, and we're going to actually solve for x. So plus 1 on both sides. Cube root it, so x take 2. Okay, I'll write it in, cube root of 1, well it's just 1, so we'll have x take 2 greater than 1, and plus 2 on both sides is 3. So on a graph, this one's a bit difficult. So we've got turning point form, stationary point of inflection, I mean. So if we graph that, the stationary point of inflection is going to be at positive 2 and negative 1, so about there. And we're going to have a y-intercept at when x is 0, so 2 cubed, take 1, oh, minus 2 cubed is minus 8, take 1 is minus 9, so it's going to go down here at minus 9. Now x coordinate, okay, would be when y is 0, so we've actually solved it here, so it's actually at 3. So the graph should look something like this. Okay, stationary point of inflection, it's not very good, but that'll do, and we solved for the values for which x is greater than 3, so it's all these values here. So that's on a graph.